In this problem, it says distinct points A, B, and C are collinear, with B between A and C. AB has a length of square root of 7 minus k, BC has a length of 2k plus 1, and AC has a length of 4k minus 3. And we want to determine all possible values for k. All right, so we have A, we have B, we have C. And for A to B, it's radical 7 minus k. For B to C, it's 2k plus 1. And then from A to C, it's 4k minus 3. So that means if we add these two, we should get 4k minus 3. So square root of 7 minus k plus, not equals, 2k plus 1 equals 4k minus 3. So in order to solve this, we're going to have to get that square root by itself. So subtract 2k and subtract 1. So we have square root of 7 minus k equals 2k minus 4. Now, to get rid of the radical, we square both sides. Now by squaring 2k minus 4, what's going to happen is we're going to multiply 2k minus 4 times the quantity 2k minus 4, like this. So this is going to be 4k squared minus 16k plus 16. Now because we have a quadratic here, we need to get this equal to 0. So we have to add k to both sides, and we have to subtract 7. So we have 4k squared minus 15k plus 9. Now at this point, for most problems like this, we're just going to go right ahead and use the quadratic formula. So negative b, which is 15, plus or minus the square root of that's b squared, which is 225, minus 4a, a is 4, c, which is 9, all over 2a, which is 8. So 15 plus or minus the square root of 225 minus 4 times 4 times 9. Let's see what that is. 4 times 4 times 9 is 144 all over 8. So square 225 minus 144 is 81. So that means we get 15 plus or minus 9 over 8. So 15 plus 9 over 8, that equals, let's see, 15 plus 9 is 24 over 8, equals 3. Then we have 15 minus 9 over 8 equals 6 over 8, which is 3/4. However, at this point, we're not quite done, because we have to check both of these to be sure that they work. So how do we do that? Well, we should be able to plug in 3 and 3/4 in for k and get equal numbers for these two. So let's see what happens. So if we plug in k, 3 in for k, we get square root of 7 minus 3, which is 4. And we get 2 times 3. Whoops, that should be 2. All right. Then we have 2 times 3 minus 1. That should be, whoops, minus 4. There's my mistake. Okay. Nope, that works. And 2 times 3 plus 1. Nope, that's my problem. Okay, so if I plug in 2 times 3 plus 1, that equals 7. And these two should add up to 4k minus 3. So 4 times 3 is 12, minus 3 is 9, so that works. So yes, k equals 3 does work. But what about 3/4? So if I take square root of 7 minus 3/4, I get some kind of decimal. So let's see that. So 7 minus 3/4 is 2.5. Then I plug in 2 times 3/4 plus 1. All right, so 2 times, we get 2.5. And then we get 4 times 3/4 minus 3. Those cancel, and we're left with 0. So that does not work. So the only value that works here is k equals 3. So really, just the only answer you need to put down is 3. And there's our answer, and we're done.